So this video will be an answer to a question from a friend of mine from India, Arindam Das. So Arindam asks to prove that the automorphism of Zn is isomorphic to the group of units of n. Okay, just check that this n obviously will be the same. Okay, so the automorphism of Zn, is that isomorphic to the group of units? Okay, that's exactly what we are going to prove now. Let us quickly remind a couple of things. So what is UN? UN is the group of multiplicative units modulo n. So there is a previous video for this if you don't remember well. I just want to call your attention that for any element A in the group of units n, each element has an inverse. So for all A, so there will be an inverse such that you get the identity. Of course, modulo n, the operation here is made modulo n. Okay, and since all this is true, we are going to pick an element A. So we will pick A in the group of units, and we are going to define a mapping psi of A, taking from Zn to Zn. Okay, and psi A of x will be in the form, let us do it this way, ax, okay, modulo n, of course, okay, because we are in Zn. So we pick psi A, taking from Zn to Zn, such that psi A of x will be ax. So this is the mapping, modulo n, the operation is modulo n. Okay, I claim that psi of A is an automorphism of Zn for all elements in the group of units. So this is the claim. I claim psi of A is an automorphism of Zn for all elements in the group of units. Okay, if I claim that psi of A is an automorphism of Zn, I have to prove it. Okay, so in order to prove that this is an automorphism, we have to prove that the mapping is one-to-one, is onto or surjective, and is operation preserving. Okay, so if you don't remember this, you just go back to my previous videos. I don't know the numbers of the videos. You just please check my list and see that. Okay, so shall we start proving that? So we'll begin by proving that psi of A is 1 to 1. Okay. Well, but this is really easy, right? Because if psi A of x equals psi B of x, so if two elements are equal, this means, so psi AX means AX, so this will be AX equals psi BX. Do not forget, this is the mapping. Okay, so psi BX will be BX. Okay, so if psi A of x equals psi B of y, I should say y here, I'm sorry, not the same element, of course. Psi B of y, no, I'm confusing all this, sorry, I'm going to restart. Okay, I'm thinking well and not writing well. Okay, if I have to pick two elements in order to show that it is 1 to 1, so if psi A of x equals psi A of y, x and y are two different elements. I cannot change this, stupid me, because psi of A is the mapping. Okay, that implies that psi A of x is AX equals AY. AY module n. Okay, so, and if, okay, let me write here AX equals AY. Now we'll put the inverse, the left inverse here, equals left inverse y, right, and this will be the identity x equals identity y, and this is, and this is, of course, x equals y. Okay, so it is proved that psi of A is 1 to 1. It's proved here. Okay, now we have to prove it is 1 to 1, so now we have to prove that it is onto or surjective, right? Okay, we have to prove that the operation is surjective, so, or onto. Do not forget that x is in Cn. Okay, so let me do it this way. I'm going to pick x, but what is x? X is A inverse, this will be the identity times x, right? Okay, now I'm going to do this. Okay, so this will be A, and this will be this element, so I can write this psi of A, right? So I just proved that it is surjective, because for every x I pick, I will have a psi A, right? So it is proved that it is surjective. Okay, now we have to prove that psi of A is operation preserving, right? Well, that's really easy. We just write psi A x plus y. So that will be, just looking at this, that will be a x plus y, but that will be ax plus ay, and that will be this one is psi of x, and this one is psi of y, right? So we just proved that, we also proved that it is operation preserving. So now I'm back. We just proved our claim. We proved that psi of a is an automorphism of Zn, where a, the a we take here, this a here, is in the group of units. Okay, we proved that psi of a is injective, one-to-one, surjective, onto, and operation preserving. Okay, so it is proved that psi of a is an automorphism of Zn. Okay, so we proved that this one is an automorphism. What Arindam does is asking another thing, is asking that any automorphism of Zn is isomorphic to the group of units. Any automorphism. We proved that psi of a is an automorphism. So now we are going to jump into a second step. What we are going to do now is to prove that I have an equivalence between this automorphism and all automorphisms. I'm going to erase this here. So what I'm going to claim now, and this is my second claim, what I'm going to claim now, this claim I proved, okay? What I'm going to claim now is that for any automorphism psi, any automorphism psi of Zn, I say that psi equals psi of a, where a equals psi of 1. So my first claim, I'm going to repeat, my first claim was that psi of a is an automorphism of Zn for all elements in the group of units. And I proved this claim. This claim I proved. But the question is, we want to prove that the automorphisms of Zn are isomorphic to the group of units. Okay, what I say is any automorphism, because I proved for psi of a, but the question is for any automorphism. So now I say any automorphism psi will be equal to this automorphism that I just proved it is an automorphism. Under this condition that a equals psi of 1, and of course now I have to prove this claim. So here I have to use induction, because if I have psi of x equals ax, right? Of course this is for all x in Zn, you know that. So let us use induction. Let us say for n equal 1, Well, for n equal 1, we have psi of 1. Psi of 1 equals a times 1. That will be a. Right? So okay. So this is the first step, right? Now the next one will be the induction step. So I claim that this is true for any value, any fixed value. So we assume that psi of x equals ax, okay, for a fixed x, and we want to see if that is true for n plus 1, right? So we want to check if that is that true for x plus 1. Okay, but what is psi of x plus 1? Psi of x plus 1 will be psi of x plus psi of 1. Okay. What is psi of x? Psi of x is ax. What is psi of 1? Psi of 1 will be psi of 1 will be a. So plus a. Okay. So I factor a and I get x plus 1. So here we are. It's in the form ax. Okay. So it is proved. So we just proved that in the previous claim we proved that this was an automorphism. We just proved that any psi any automorphism will be equal to this automorphism. Okay, of course under this condition. Okay, so we proved that by induction. So first I claimed that psi of a is an automorphism. I proved that psi of a is an automorphism, and then I claimed that for any automorphism psi, any automorphism, not only psi of a, any automorphism psi would be equal to psi of a under this condition, and we just proved by induction that yes, any automorphism psi is equal to psi of a. Okay, so all this work, and now we have this, we can work with these two automorphisms. These automorphisms are equal. Okay, so now we are going to define an isomorphism f. I'm going to call the isomorphism f from the group of units to the automorphism of Zn, and this mapping will be given by psi of a. You know psi of a by now. So f maps the group of units onto the automorphism of Zn. Okay, so here I'm proving that f is an isomorphism, so this will be the final step, right? F will be an isomorphism from Un to the automorphism of Cn. That's exactly the question. If the group of units is isomorphic to the automorphisms of Cn. Well, my first argument is that this was isomorphism, this mapping, first I have to say it's a mapping. from the group of units to the automorphisms of Zn under this f of a psi a is onto. Well, in order to prove that this f is onto, let me write, to prove that this f is onto, well, just check the previous claims. Okay, it's abundantly proved this. Okay, I think we just need to prove that f is injective and f is operation preserving. In order to prove that f is 1 to 1, we pick two elements, f of a equals f of b. This implies that, so we are calling psi of a, right? Psi a of x. This time is f of b is this, so this time is different from the previous one where I got it wrong. So this will be the same element, right? Because f is a mapping, okay? But what is f? F is psi. Okay, so f of a equals f of b. So for the same object, I'm not wrong this time, for the same object, so f of a equals f of b, psi of a of x equals psi b of x. Of course that this is for all x, okay? So what is the element a? The element a will be a times 1. But what is a times 1? Is psi a of 1. Okay, but psi a of 1 so psi a of 1 will be psi b of 1, right? If f of a equals fb, then psi a of x equals psi b of x. So psi a of 1, I pick this one, I get to a, and psi a of x equals psi b of x, so psi a of 1 equals psi b of 1. This one will be b1 and that will be b. So if this is true, a will be equal to b. What we have here is a equal to b. So it is proved that f is 1 to 1. So we just need to prove that it is operation preserved. Okay, we pick x in Zn, and let us say we have psi a, and we do a composition here, a left one. So what is psi b of x? Well, psi b of x is bx, right? Okay, and what is psi a of bx? Is a times the element, right? So this will be abx. Okay, but if you look well, abx is nothing else than psi ab of x, right? So f of ab equals to psi of ab, and this is equal to psi of a psi of b, and that is f of A, f of B, right? So this shows that f is operation preserving. Well, this concludes the theorem. I keep saying this concludes the proof. So first we made two claims. We wanted to prove that all automorphisms Zn are isomorphic to the group of units. First claim, psi of A is an automorphism of Zn. So we picked a particular automorphism. It was this one, psi A of x, Ax, and we proved this claim. We proved that psi of A is an automorphism. Then we jumped into a second claim. We said for any automorphism, that was our second claim, for any automorphism psi of Zn, this automorphism will be equal to this one, right? It will be equal to psi of A. And we proved this claim. So we proved that all automorphisms are equal to this automorphism. So next step, we defined this f as an isomorphism. This is very important, isomorphism. We picked f, we defined f as an isomorphism from the group of units to the automorphisms Zn, and we defined it this way. By the claims f, it was proved that f was onto. It was really easy to check that f is injective, and it was not very hard to prove that f is operation preserving. Okay, it should be, yes, here. So we proved that f of AB equals f of A times f of B. So it's operation preserving. So we just proved that f is an isomorphism. We found the isomorphism from the group of units to the automorphisms of Zn. Any further question, just contact me through the usual media.